Hi class, I'm going to give you a little tutorial about the standard deviation for the difference of two proportions. It's a little bit tricky and I just want to make sure you get it. At this point on your worksheet, you should have gotten to question number 4 and maybe you're thinking, difference of two proportions or difference of two random variables. I remember that from the Pete and Aaron Jeep tour thing. This is going to come in really handy, that Pete and Aaron Jeep tour information, for when we're calculating a confidence interval or even calculating the standard deviation for a hypothesis test. So you may have gotten down to question 7 and thought, well, okay, I can kind of wing this. I know that for a regular 95% confidence interval, I would do p hat 1. I'm going to go ahead and say this one's p hat 2 minus p hat 2 plus or minus this z star thing times the standard deviation of what, and maybe gotten stuck here. So let me show you where we're going to actually derive the standard deviation formula. So we know that for one proportion, the standard deviation is the square root of p times 1 minus p divided by n, right? P is the proportion, n is the sample size. Now the problem is I've got P1 and a P2. I also have two different sample sizes, so I want to make sure I've got an N1 and an N2. From the Pete and Aaron Jeep tour thing, hopefully you remember that when you either add or subtract two independent random variables, you're still using that Pythagorean theorem of statistics idea. So we're going to say if this side represented the standard deviation of P1, this one is P2, then this one here would have to be, if you think about a squared plus b squared equals c squared, this would have to be the square root of the standard deviation of P1 squared plus the standard deviation of P2 squared. So let's use that and derive the formula for the standard deviation of P1 minus P2. All right, so we know the standard deviation of P1 is right here, standard deviation of P2 is right here, and we know from this equation up here that we've got to square P1, square P2, square the standard deviation of P1 and P2, add them together and take the square root. So first, I could start and say, okay, so a squared plus b squared equals c squared. This guy right here is kind of like my c squared. I'm going to say that this would be equal to my a squared plus my b squared and I can substitute in the values that I have this square root value for P2 and P1 instead. So I can say, well, this thing is equal to the square root of P times 1 minus P1 over N1 all squared plus the square root of P2 times 1 minus P2 over N2 all squared. And as you hopefully remember, when you square a square root, they essentially cancel themselves out. So squares going to cancel that part out. This squared will cancel this part out. So now, oops. If we look over to the left, it's still not equal to what I want it to be equal to, right? This standard deviation is still squared, so really it's being equal to the variance right now. So in order to undo squaring this part, I'm going to have to take the square root of both sides. So the square root of this guy, square root of this guy, leaves me with the standard deviation for P1 minus P2 equals the square root of this whole big mess. So P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 all divided by N2. This formula is going to be used mostly for confidence intervals. So standard deviation obviously when you do this with a confidence interval, you're going to have to throw in the little hats because we don't actually know what the true proportion is, but we know what our sample proportion is. If you look at the AP formula sheet, if you're on our website, if you go to the Part 4 section and go down to the Skittles page, the AP formula sheet is linked right here. And if you go down to the second page, you'll see we've covered for one population. These formulas should look familiar. For two populations, we have this P1 minus P2 thing. The parameters of the sampling distribution, so that would be for the population. If you knew the population, then this is the formula that you would use. If you need the standard error, this formula right here, that should look very familiar. That's the one we just derived. This down here, when P1 equals P2 is assumed, is something kind of interesting, and we'll get to that later.